Question 5b. The diagram shows a conical drinking cup of height 12 centimeters and radius 4 centimeters. The cup is being filled with water at the rate of 3 cubic centimeters per second. The height of water at time t seconds is h centimeters and the radius of the water's surface is r centimeters. Part 1. Show that r equals 1/3 h. The right-angled triangles inside the cone are similar, so the corresponding sides will be in the same ratio. Hence, r over 4 is equal to h over 12. Multiplying both sides of this equation by 4, we get r is equal to 4 times h over 12, therefore r is equal to 1/3 h as required. Part 2. Find the rate at which the height is increasing when the height of water is 9 centimeters. Volume of cone equals 1/3 pi r squared h. By the chain rule, dv dt is equal to dv dh times dh dt, where v represents the volume of water in the cone at time t and h represents the height of water in the cone at time t. We'll call this equation number 1. Now the volume of water in the cone is given by the formula v equals 1/3 pi r squared h. But r is equal to h over 3 from part 1. So expressing v in terms of h, we can eliminate the r by replacing r with h over 3. So the volume v can be expressed entirely in terms of h. So v is equal to 1/3 pi times h over 3 squared times h, which simplifies to v equals pi h cubed over 27. Now dv dh is the derivative of this formula here, so dv dh is equal to pi h squared over 9 and dv dt is equal to 3 cubic centimeters per second. This is given in the question. So from equation number 1, 3 equals pi times 9 squared over 9, so we're interested in the rate of change of the height of water with respect to time when h, or the height, is 9 centimeters, multiplied by dh dt. So we need to solve this equation for dh dt. So rearranging this equation to make dh dt the subject, we get dh dt is equal to 1 over 3 pi centimeters per second. Therefore, the height is increasing at a rate of 1 over 3 pi centimeters per second when the height of water is 9 centimeters. The following is the feedback from the Marking Centre for question 5b. For part 1, candidates were required to show that r equals 1/3 h. Many candidates gave no indication of similar triangles but were still awarded the mark for correct proportion statements, such as r over h equals 4 over 12. The most common error was for candidates to substitute the values r equals 4 and h equals 12 into r equals 1/3 h. This approach did not gain the mark. Some candidates ignored the diagram and tried to use the formula for volume to show the result. For part 2, generally this section was well done, with candidates demonstrating a clear understanding of the use of a chain rule and at times some creative approaches to manipulating r, h and v. The most common error, however, was to differentiate the formula for volume in terms of r and h and simply treat one of the variables as a constant. This approach only allowed candidates to gain 1 mark out of 3. Many candidates were let down by poor arithmetic and algebraic skills. When using a chain rule, poor handwriting and/or use of notation made it very difficult to decipher what candidates were meaning, with dv, dr and dh being indistinguishable.